Hello everyone. So today we're going to learn how to assign electron configurations to elements. And a really simple way to think about this is that the electron configuration of an element is like its address, and it only has one address. So that's one way that you can pinpoint a specific element. And these are questions you will see on your DAT or your MCAT. Let's quickly dive into some background before we jump into assigning electron configurations. So I'm sure you know all about different shells and orbitals, but really quickly it's important to understand that the S, when you're looking at the S orbital, it has one orbital and it can hold 2 electrons. When you're looking at p orbitals, it has a max number of 3. It can hold a max number of 6 electrons. When you're looking at the D, it has 5 orbitals and it can hold a max of 10 electrons and so forth. And they're not going to test you past G. There's no point in that. So we need to understand the formulas really quickly. So if we want to figure out how many orbitals are going to be within a specific element, all we do is we look to see which shell we're in, which I will show you in just a minute. Anyway, we will go ahead and use the formula n squared. And this is going to give you the number of orbitals. I'm going to come down here to an example really quickly. So if we're in shell number 4, we're going to have 16 orbitals because 4 squared is 16. And if we want to look at the max number of electrons, it's just as simple. You just multiply it by 2, so that gives us 32 electrons max within that shell. So you might be asking, well, what are these shells? I have absolutely no idea. And that's okay. So the shell is just basically going to we're just going to work our way down the periodic table. So right here at this hydrogen, this is shell number 1. This right here at lithium is 2, 3, 4, 5, and so forth, and you just work your way down. It's that simplistic. I am going to go ahead and draw you a periodic table that will work as a cheat sheet. Alright, now you have a cheat sheet for the periodic table. You can compare it to an actual periodic table, and you can see the way in which different shells get filled out and which different orbitals are within those. So the only thing that you need to keep in mind is that when it comes to the transition metals, and we're going to be looking at D, it is one row behind. So if you're naming something and you're going off of the 4S, if you go to the right of it, it's going to be 3D, not 4D, because it's one behind. And then when it comes to the Fs, these are 2 behind. And we'll go into examples and stuff. I guess the best way to go ahead and learn is to jump right in. Now that we have our periodic table, we can go ahead and get started with the example. So if you want to find the electron configuration for nitrogen, the way to start is we're going to first go by longhand, and then I'm going to show you the shortcut. So let's go ahead and start the first element, which is going to be called hydrogen. And just so you know, that when you go ahead and look at this helium over here is still going to be considered in the S, so that is something to keep in mind. So this hydrogen right here is going to be 1S1. This helium is going to be 1S2. So when we go ahead and write this out, the formula, we're going row by row, so we're going to have 1S2. Pretty simple, huh? So we're going to come down to the next row. We can see right here, this is, since this is the second shell, 2S. We're going through both atoms, or both elements, so 2S2. And then we're moving over to here. Let me go ahead and write this within the formula. 2S2. And this is the P rows. So how many P's do we go till? So we go to 1, 2, 3. So this is going to be 2p3. And that actually is the formula for nitrogen. Let's go ahead and do another example. Let's choose for our next example bromine. Oh, but look, bromine is all the way down there, so this is going to take us a while. Actually, if you want to use a shortcut, and this is a shortcut you're going to be using on your test, whether you're taking the MCAT or the DAT, you go ahead and you find out which of the noble gases precedes which different element that you want. So we can see right here, argon is the noble gas that precedes bromine. So the special format we can use is we can just write A, R, and we're going to put it in brackets like that. And now we can go ahead and start naming from here. So we can go 4s2, and now we're coming to the transition metals, and this is why I picked this example. These transition metals are not going to be 4D. That's incorrect. They're going to be 3D, because you have to remember they are one behind. So you have 4s2, then we're going to have 3D, and there's 10 of these. And then we're going to move back to the 4, since we're in the P. 4P, and we go 1, 2, 3, 4, 5, 5. And that's really all there is to it. Now, there are some exceptions when it comes to the this test, and I guess I'll go ahead and jump into them really quickly, just because you might see them on test day. The rule of thumb is that the transition metals they feel more stable if their orbitals are completely full or half full. So the exceptions that you should definitely be aware of for your test are going to be copper, silver, gold, chromium, and molybdenum. So let's go ahead and use copper as an example. So, what do you think the electron configuration would be? You can go ahead and pause this video and try it for yourself, then I'll go ahead and complete it. Alright, so if we're going to go ahead and use the shorthand, and I should not have capitalized that like that. Let's redo this. You can see right here that copper ends with 3D9, which is interesting because the transition metal, and like we said before, transition metals like to be either half full of their orbitals or completely full. So how could we take this copper and make it have a full set of electrons in its orbitals and to be happy? Well, it's actually quite simple. What typically people would do on their tests is write 4s2, 3d9. And if you did this, you'd be incorrect. So we're going to take an electron from the highest shell we have, and we are going to go ahead and steal it, basically, and give it over here like this. So that is going to go ahead and give us 4s1, 3d10. And this would be the correct formula for copper. Let's go ahead and try one more out just to make sure you get the principle. Let's go ahead and use CR. So how would you go ahead and write the correct electron configuration for CR? Now I'm going to go ahead and write out the incorrect way. So again, we're going to want to do shorthand notation just because you're going to want to save time while you're on your test. And we're going to come down here, we see we're in 4s. So what is going on here? Okay. 4s2, and now we're in the 3D because remember we're one behind. So 1, 2, 3, 4. So 3D4. Now, like I said, the transition metals either want to be completely full or halfway full. So one way to make this halfway full would be to go ahead and steal an electron from the 4s2 and donate it to the 3d4, and that would give us 4s1 3d5, and that would be its correct electron configuration. I did not mean to make this video 11 minutes long, but I guess this is important information. If you have any questions, feel free to just go ahead and email me or leave a comment below, and I'll get back to you as quickly as possible. Good luck studying.